So today we are going to talk about data. There are two data types. One is your grouped data type and your ungrouped data type. Grouped data type is classified as discrete. When we talk about discrete data, we refer to all that data types wherein there are discrete values, and for those discrete values you have a certain set of frequencies. For those kind of data we call them as discrete data, and the other one that we have is a continuous data. A continuous data is where we have basically class intervals. So let us understand what is a frequency. A frequency is a certain observation and the total number of times that an observation has repeated. Let us take an example. We have the values of x, and these are the class intervals given. The class intervals are between 10 to 20, 20 to 30, 30 to 40, and 40 to 50. And the number of observations that are seen between the class interval are given to be 5, 6, 4, and 4. So the total number of it's 5. The total number of observations that we have are 20. So what is basically a range? A range is the distance between the two classes. So if I take the first class as 10 to 20, the 10 is the lower limit of the class and your 20 is the upper limit of the class, whereas the distance between the class is 10, which is upper limit minus lower limit, which is equal to 10. Similar to that, for every other interval the range is going to remain same. You can represent the range as d, which is 10. Now when we have an inclusive class interval, and an inclusive class interval is different from an exclusive, like the data that we have given on the right hand side, 10 to 19, 20 to 29, 30 to 39, and 40 to 49. These all are called as inclusive class intervals, whereas x, where x is equal to 10 to 20, 20 to 30, and so forth, are called as exclusive class intervals. So we need to understand the class marks. Class mark is given by the value upper limit plus lower limit divided by 2. Now let us take a sum. This sum is for the number of telephone calls attended and the time that has spoken, and we will note down the values. So we are going to prepare a frequency distribution table for the same, and let us go ahead with making a note of the observations. Now this is basically raw data. What do you mean by raw data is that these data is not grouped, so we can call it as an individual series data. We are going to understand the first part of statistics is when we have our raw data, how do we go ahead with grouping the data. So we have these number of minutes that a person has spent on every call that is made, 5, 6, 7, 8, 9, 7, and so forth. So what happens with your frequency distribution is that in a frequency distribution we are going to prepare the number of classes in which this data would be collected. So in all we have got these observations. So total we have around 30 observations, and for these 30 observations we are going to prepare the frequency distribution table, right? So first of all, we need to identify which is the lowest value in this and which is the highest value. So just by observation we see that the lowest value is 5, whereas the highest value is 10. Now the total number of observations are 30, and we need to prepare the frequency distribution table. Now while preparing a frequency distribution table, you need to keep in mind about how you set up your classes. So you can take as per your choices, but in this case what we see is that these classes need not be done because we will going to form a discrete series distribution. So let us do that. As per the discrete series distribution, we are going to take down individual values and find out the number of times that they have repeated. Since we have got values 5, 6, 7, 8, 9 and 10, these values have been repeated over a period of time. So we write down the values in one column as x, 5, 6, 7, 8, 9, 10. And now we need to prepare tally mark. What is basically tally mark? Tally mark is a method to mark the number of times that an observation is repeated, right? So for the value of 5, we are going to make a note of it. Every time that one particular observation is repeated, we will put a mark for that. So you can see in our data the value 5 has repeated 4 times. So we are going to put 4 straight lines for our tally mark, and the frequency of the 5 is 4 times. Similarly, for the value 6, we are going to find out how many times 6 has repeated. 1, 2, 3, 4, 5. Right, so 5 times it has repeated. So we put the tally mark as 5, and the value of f is 5 for x is equal to 6. Similarly, we will repeat the process for 7. So 7, it's 1, 2, 3, 4 and 5. So its value of 7 is also repeated 5 times, and we put in the tally mark for 5. For 8, the value is repeated 1, 2, 3, 4, 5, 6, 7, 8. So the value 8 has been repeated 8 times. So we will put a tally mark for 8. Right. And similarly we'll proceed with the steps for 9. So 9, 1, 2, 3, 4, 5. Yes, that's it. So 6, there are 6 values for 9, and hence we will put the values of f is equal to 6 for x is equal to 9. And for the value of 10, we will repeat. It's 1, 2, and that's it. So the value of x is equal to 10, it's 2, right? So the total of f is equal to 30. So you will find it out. It's 4 plus 5 plus 5 plus 8 plus 6 plus 2, which is equal to 30. This is how basically you prepare your frequency distribution for the data given. Okay. If you have any queries, you can get back to me about the same. So far we have understood about how to prepare your frequency distribution from a raw data set that has been given to us. In the coming sums, we are going to identify the preparing the frequency distribution uh, in a continuous series data. So what exactly the current data that you were looking at is of the form discrete series. So basically we have prepared a frequency distribution of data which is in discrete series form, and in the coming sum we are going to see and prepare a frequency distribution for a continuous series data. Now I'll prepare a continuous series data, we need to understand on how we prepare the class intervals. And for preparing the class intervals, you need to be aware about how much should be the distance between each of the classes. So while doing so, if you would take the raw data, every time that the raw data comes within a certain class, we need to put that within that particular class interval. So let us take another sum. We are going to note down the data values and we will proceed with solving it. So what exactly is data? Data can be considered as any numerical values which represent a certain value of, let's say, we can call it as weight, height, as such. So when I say data, data could be anything related to, like, let's say if I want to take weights of 50 students in this class, I can put the data as 50 students, and for those 50 students it would be the weight. So let us take this data. This is 37, 42, 40, 50, 62, 40, 38, 48, 43, 39, 55, 52, 52, it looks like 62, that's right, 50, 49, 35, 61, 60, 49, 56, 60, 45, 53, 46, 36, 42, 36, 64, 61, 54, 50. So 35, 40, 47, 61, 50. So in all we have around 5, 10, 15, 20, 25, 30, 35 and 40 such observations. And with these 40 observations, we are going to prepare a frequency distribution. But while preparing the frequency distribution, we are going to consider the class intervals, right? And for class intervals, again, the first thing we need to do is we need to find out what is the lowest value in this data set and what is the highest value. So the lowest value in this data set is 35 and the highest value in this data set is 61. right? I believe 61. No, it's 64. So we will prepare our class intervals keeping 5 as the distance, and the classes would be 35 to 40, 40 to 45, 45 to 50, 50 to 55, and 55 to 60, 60 to 65. Now the objective of keeping such kind of class intervals is because we need to take into account the lowermost value of the data set and also the uppermost value of the data set, and we are going to group them. You must have observed that the upper limit of the first class is equal to the second limit, the lower limit of the second class, and so forth. So the reason why it's so, it's because it is a continuous series distribution. So we have prepared this class intervals, and we are going to prepare tally marks. So again, like in previous example, we had seen tally marks. We are going to prepare tally marks, and this time, instead of marking directly against the frequency of x, right, we are going to put them in groups, and every particular value which is within the group would be taken into account. Now these classes are exclusive. The meaning of exclusive is that any such values which are lesser than the upper limit of the class would be considered, whereas values which are equal to or greater than the upper limit would be considered in the next class. For example, our first class is from 35 to 40. So in this case, if we get any such values, that is 40, right, 40 is greater than 39, so this particular value will not be taken in the first class, that is 35 to 40, but we will be taking that value in the second class, that is 40 to 45. This thing you need to keep in mind, because when you are preparing the frequency distribution, you always need to take into account the lower limits and upper limits of the continuous series data, and also you need to identify whether the classes have been given are exclusive or inclusive. In other words, when I talk about exclusive means that the upper limit is not taken into account, okay, whereas when I talk about inclusive class intervals, basically the upper limit is taken into account. So in fact, in an inclusive class interval, you would have both the upper limit and the lower limit, whereas in an exclusive class interval, only the lower limit is taken into account and the upper limit is not considered, right? So here we have our data, which is basically from 35 to 40, 40 to 45, 45 to 50, and 50 to 55, 55 to 60, 60 to 65. For each of these classes given, our data is, the distance is basically 5, right? Now we have taken it as per our convenience, so you can decide the class intervals. It is highly suggested that you should have equal class intervals across the data set, and that would help you to find out. So we have our lower limits of the first class as 35 and the upper limit is 40. Now while considering these values, we need to take into account each and every data observation that is there, and every data observation, where exactly would it come, is what we need to understand. So while doing this, we will look at each of the data values and understand its working, right? So I hope you have understood so far the facts about data. We have understood what a data is, we have understood what is a class interval, we have known about the distance between the classes, we know what exactly is a tally mark, also we know on what exactly is your frequency, and while this has been clear, let us now go ahead with plotting the frequencies and the tally mark for the given data. So the first thing that we will do is we will set up the frequency directly. So no need for putting in tally marks, because I believe now that a tally mark is quite understood. We will look into how exactly we can classify the data in this specific class interval. So let us take into account the first value, right, 35 to 40. We will need to see on finding out how many such values lie between 35 to 40. So it's 37, 36, 35, 38. Then it's 36 and 35 and 39, right? So basically there is 1, 2, 3, 4, 5, 6, 7 such values. We can't take 40 into account because 40 is the upper limit of the first class, and we exclude it. So we have 40, 42, 40, 40, 43, 43, 40. No, we can't take 49, but we can take 42, right? So the total number is 7, right? Let's continue. So 45 to 50, we have 45, 1. Next is 47, 2. 46 is 3. 49 is 4. And 48 is 5, right? Again, we have 49. Then it's alright, I believe that's more than enough, so we have put it as 6. Right, now let's take from 50 to 55. It's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8, 9, 10. Okay, so we have 10 such values, right? Between 50 to 55. 1. Now it's 55 to 61. 2, 3. It's 3 such values. And now from 60 to 65 we have 61, 1, 60 is 2, and 60 is 3. It's 4, 5, and 6. So we have 7 such values. So now ideally the total of frequencies should be exactly equal to 40. So it's 7 plus 3 is 10, plus 10 is 20, plus 14 is 34, plus 6 is 40. So therefore n is equal to 40, and our tally is correct, right? So this was one of the examples for setting up your data in a continuous series distribution. So what we have done is we have converted your data from basically an individual series, and we have grouped the data, right? We have grouped the data accordingly. Okay, so so far we have understood the concepts of continuous series data. We have understood what is your lower limit, what is your upper limit, what is the distance between the classes, what is your frequency, and we have the total number of observations, which is represented by n is equal to 40, right? So let us look at the next example. The next example, we are going to understand about our data and see on how exactly we sort out the data, right? So let us note it down. X is 24, 26, 27, 25, 28, 27, 25. So accordingly we will make a note of the data that we have, and we will prepare a distribution. Earlier we had seen a distribution for a discrete series data, then we saw the frequency distribution for a continuous series data. Now we are seeing the distribution for a bivariate frequency. So basically what we mean by a bivariate frequency is, this is a bivariate frequency distribution. What they mean by this is that we have two values. Instead of having only x, now we have got y as well. So we have got two variables, x and y, and we have a pair of n observations. So let us say that I want to compare the weights of boys versus the weights of girls. Now here the weight is counted in kgs, whereas there are two different groups of data. One is x, which is the weight of boys, and the y, which is the weight of girls. Whenever there are such two variables encountered, we call that as a bivariate frequency distribution. So for a bivariate frequency distribution also, we need to understand on how we set up the data, because for a bivariate frequency distribution we have got two variables, and each variables need to have their own individual class intervals, and this becomes a little complicated because earlier we were dealing with only values of x. Now we need to find out x as well as y, so it can sometimes be a little tricky situation, but don't worry about that, we will see that accordingly. Alright, so we write down the values 25, 25, next is 26 and 25 again. Now while preparing a bivariate frequency distribution, we need to understand on setting up the distribution table. Now while setting up the distribution table, we will go ahead with setting up in such a way that it should be able to take the class intervals of both x as well as y. So we will quickly make a note of this. Now let us count the total number of observations. So for the pair of x and y, there are total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 and 24. So in all we have total 24 pairs of observation, and for these 24 pairs of observation we are going to prepare a bivariate frequency distribution. So how exactly do we prepare a bivariate frequency distribution, and how would we tabulate our data is what we need to understand at this session. So first of all, when we take into account, we need to again find out what is the lowest most value of x and the highest most value of x. Accordingly, we need to set up our class intervals. So as per the data that we have, we see that the lowest value of x is 24 and the highest value of x is 32. Right, so we can set up data in the form of 24 to 26, keeping the distance of 2, 24 to 26, 26 to 28, 28 to 30, 30 to 32. Alright, and similarly for the values of y, we have the lowest value is 18, right, and the highest value is 26. Right, 26 is the highest value. So in this case, when you have the values of y, we can set up the class intervals as 18 to 20, 20 to 22, 22 to 24 and 24 to 26. So now that we have identified and understood what exactly are our class intervals both for x and y, we will go ahead with setting up the table. Right, so we draw a table like this, which is representing both the class intervals. On the vertical side, you can take the class intervals for x, and for horizontal line you can take the class intervals of y. You can decide accordingly what you wish to take, right, but it's always suggested that you can keep it x and y. Right, so let us do that for y. It's 18 to 20, 20 to 22, 22, it's 18 to 20, Next is 20 to 22, 22 to 24, and 24 to 26. Right. Now, this particular data that we have taken, right, so this is basically what we are doing is we are taking this as an inclusive class interval. So what's the advantage of having inclusive class interval is that these values won't be any more confusing. So we will take it from 18 to 20, 21 to 23, and 24 to 26. Okay. Similarly, on lines of your x, it will be 24 to 26. Uh, mhm. It's 24 to 26. Next is 27 to 29, and 30 to 32. Okay, so I believe that because of this our class intervals have reduced. So instead of taking 18 to 20, 20 to 22, 22 to 24, and 24 to 26, now since that both the classes basically, since it's an inclusive series data, our classes have reduced and our table has also considerably reduced. Now let us look at the first pair of observation. So the first pair of observation is 24 and 22. So wherever the value of 24 and 22 lie, so the value of 24 lies in the first quadrant of x, which is basically 24 to 26, basically the first class interval, whereas the value of y lies in 22, which is basically between the class interval of 21 and 23. So for that case we will need to plot that particular mark or the class mark at x is equal to 24 to 26 and y is equal to 21 to 23. Right, so we will do that. Just give me a minute. Yes, you all need to remember one thing is when you are putting down your class intervals, it's highly recommended that if you are falling short of your space, you need to look at alternative methods for suggesting your class intervals as well. So either you can decide for your data to be exclusive or inclusive. Okay, so it doesn't matter if your data is, if your class intervals are exclusive in nature or if they are inclusive in nature. You can just accordingly prepare your tables and mark the data. Right, so our first pair of observation is 24 and 22. Right, so we will prepare the table. So the first class mark that we put, the first tally mark that we put for 24 and 22, it will be x basically is 24 to 26, so the value lies between the first class interval of x and the value y, which is 22, which lies in the second class interval of y, which is 21 to 23. Alright, so we will put one tally mark over there for now. So we will cut down 24 and 22. Right, now accordingly we will look at the second one, which is 26 and 21. So 26 and 21 again come in the same class. Now for 27 and 23, so it's 27 and 23. The value of x is 27 in the second class interval, and for the value of y it's 23, it's in the second class interval. And accordingly, for the rest of the values we are going to put the class marks. So 25, 2 and 20. So the value of 25, x is equal to 25, is between 24 to 26, and the value of y, which is equal to 20, is between 18 to 20. Since it's an inclusive class interval, we consider both the classes and both the class limits, upper limit as well as the lower limits, because it's an exclusive series data. It's an inclusive series data. So accordingly we will go ahead with marking them. Let's do that quickly. Right, so 25 and 20 is done. Right, so it's 28 and 24 comes in the between 27 to 29 and 24 to 26. Now 25 and 18 would be marked in between. Right, now 26, x is equal to 26 and y is equal to 19. Right, x is 28 and y is 23. X is 30 and y is 25. X is 25 and y is 19. Right, we will cut that. X is 27 and y is 22. We'll cut that. X is 28 and y is 24. We'll cut that as well. X is 29, y is 24. Okay, next x is 30 and y is 25. Okay, next is x is 31 and y is 25. So x is 32, y is 26. Next is x is 30 and y is 25, so we have to put it accordingly. So after 5 we put it across. Next is x is 25 and y is 21. Right, so we have marked it. Now x is 26 and y is 22. Right, so we have crossed that as well. And x is 30 and y is 26. X as 31 and y as 25. Okay, and x as 24 and y as 23, and x is 26 and 24 and 23, yeah, and x is 26 and y is 22. Okay, so we are done with marking all of the class. Right, now let us go ahead with preparing your table. Right, and now ideally the total of all of the values should be equal to 24. So the first one is 4, the second one it's 6, the third one it's 4 again, and the fourth one is 3, and the fifth one is 7. Okay, now either ways, if we take it horizontally or we take it vertically, the total of all the values should be equal to 24. So let us do that. So it's 10, 7 and 7. Right, so 7 plus 7 is 14, plus 10 is 24. Similarly, if we take it vertically, it's 4, 10 and 10 again, which is equal to 24. So either if you take it horizontally or either if you take it vertically, the value is 24. Now bivariate frequency distribution needs to be understood very well, because when we are dealing with bivariate frequency distribution, we need to understand about your bivariate frequency, and there are a few areas where bivariate frequency distribution is applied, especially when we are dealing with correlation. So in such cases, we need to prepare your bivariate frequency distribution. Alright, so if you have any queries, you can get back to me on my WhatsApp number, or you can email to me as well regarding any such issues that you might face. Right, thanks a lot guys. Have a good day. Bye bye.